Hello students, welcome to our Asian International School online tutorial class. Today in the chapter Light we are going to learn the topic images formed by a convex lens. A convex lens, depending on the position of the object, can create different kinds of image, and there are a few cases, 6 7 cases are there. We will learn one by one. So in the first case, you can see this is the convex lens and the object is at infinity. Since the object is at infinity, light will come parallel. Any object placed at infinity from any aperture or the observer will see the lights parallel regardless the object size. So here the object is at infinity, the light are coming all parallel. You can see these lights are parallel, so that's why we have drawn parallel lines. Now in this case the lights are parallel to themselves as well as they are also parallel to the principal axis. This is the principal axis and the lines are also parallel to it. So what happens after refraction? You can see after refraction all lines they converge at a point, and we know the point name is focus f2 since it is on the right side of the lens, so we name it as f2, and the f1 will be at the side of the object always. So all the lines after refraction will be focused at a point, it will be converged to a point, and we know that point, that is the focus. So what kind of images will form in this case? We can see here the image will be a point size image. The position of the image, if it is at f2, then it will be a point size image. So it's a point size image, it's highly diminished and also it's inverted since the lights are, you can see they are converging to a point, so it will be inverted. And since all the lines are meeting at a point, really they are meeting at a point, so it will be a real image. So characteristics of the image will be, it will be a real, diminished and inverted. This is the first case. Let's see the second case. And in the second case you can see here object is placed beyond the center of curvature or 2f. So if the object is beyond the center of curvature or 2f, then let's say this is the object, you can see the object is placed upside, it is placed like here, this arrow is the object. Now what will happen, just like before, we know what we have to do, we have to draw a line parallel to principal axis which will fall on the lens, and another line which will fall on the optical center of the lens. This is the optical center O. So the line which is coming parallel to principal axis after refraction will bend towards the lens and towards the normal, and it will go through the focus, and the line which is passing through the optical center will not be deviated at all. So they will pass like this, and the two lights will also meet at a point here. You can see the point here, it is meeting at this point, so we can say that image will form here. So you can see the image is definitely forming due to the meeting of two lines, so it is a real image. And also it's inverted, you can see it's upside down. This is the object placed like this and the image is like this, so it's upside down, it's an inverted image. And if we see the size of the object and the image, if we compare it, then the objects the image size is smaller, the object is bigger here, the image size is smaller. Now if we see the distance from the center, the optical center of the object and the image, we will see that the object is at a higher distance than the image. So object distance is higher, so object height is also higher, and image height is also smaller and image distance is also smaller. So this is the second case. Like this there are more cases. Every time we see images are formed. Now I will show you how the drawings are done. All these characteristics I will also discuss at the same time. Okay, now let's see how the drawings will be done. Okay, so we can see we have drawn the lens here. This is our convex lens and this is the principal axis. Now the first case we will draw first. That means the line, the object is at infinity and the line or the lights coming are parallel to themselves. This is one, this is another one. Let me take one more set below. Alright, so these are the incoming lights. Now we have to give the arrows. Always give the arrows. Arrows are must for any kind of light drawing. Alright, so they will be all refracted. We know how they will be refracted. They will be all refracted from the focus. If we do that, they will do like this, then this one, and this one. So we see what happens here. The lights after refraction, they are passing through the focus, and they are, after that they are diverging. So definitely it is a point size image. This is a easy drawing. This was an easy drawing. Let me draw the second one. Alright. For the second one, once again what we will do, first we will in this case the object, we will take the object at beyond C. So let me take the object like this. Alright, now you know what you have to do. You know that first the parallel line from the head of the object parallel to principal axis. Second one will pass through the optical center. Now we know what will happen. This line, which is parallel to principal axis, will refract through the focus. Just a minute. Come from here. Okay, done. So you can see what happened here. Okay, so this is the meeting point. That means the two lines are meeting at this point. So the image will formed here. The image will be formed right there. If I draw the image, then the image will be like this. Okay, so this is the image. So clearly you can see how the drawing is done. First I draw the parallel line parallel to principal axis, then I draw this line, this through the optical center, and there after the refraction this parallel light will pass through the focus, and these two will finally meet at a point. Now we can see this is the image formed. So characteristics of the image is clearly it's a real image, it's inverted, and if you check the size, then the size of this image will be smaller than the object. Clearly it is smaller than the object. And if you check the distance from the object to the optical center is also more than is more than the distance of the image to the optical center. Okay, so that's how this drawing will be done. Now let's check the third one. Okay, in the third case we will place the object at C. So let me place the object at C. Okay, good object. So what will happen? As always, first light parallel to principal axis. Second light will pass through here. I'm drawing it already because there will be no deviation, so let me just complete that. Okay, and this line, we know what will happen to this line. This line will pass through the focus. If I pass it through the focus, it will be right here. Okay, now if I give the arrows, now you can see the two lines after refraction meeting at this point. So definitely this is the image point. This is the point where the image is formed. So if I draw the image, the image will be this one. Now clearly we can see the image is forming at the center of curvature. The object was placed at the left side of the convex lens and the image is formed at the right side of the convex lens, but the distance is same. This is at center of curvature 2f1, this is also at the center of curvature c2 or 2f2. So here we can see that the image which is formed here is definitely real and it's inverted. If you check the size will be same. The distance from the object to the lens and distance from the image to the lens is also same. Now let's check the third one. Okay, now in this case we will place the object between the f1 and 2f1, that is focus and center of curvature. If you place the object between the focus or the center of curvature, focus and the center of curvature, then okay, this is my object. First light parallel to principal axis here, second light passing through the optical center. Done. Okay, now we know what will happen. The line which is parallel to principal axis will refract through focus. If we do that, then this will be done. Okay, now let me give the arrows. Okay, this is the arrow for the incident, this is the refracted. Okay, so this will be the image point. You can see the two lines are meeting at this point, so this will be the image point. So if I draw the image, then the image will be looking like this. Okay, so this is the image. So clearly it's a real image, and the object size is smaller, you can see in this case. So the image is real, it's inverted, but it's enlarged, it's bigger, it's enlarged, it's bigger than the object. And if you check the placement of the image, then the image distance from the center, from the optical center, is more than the object distance from the optical center. So you can see it's they are correlated. The distance from the center is correlated to the size. If the distance from the optical center is higher, then the size will be bigger, and if the distance from the optical center is lesser, then the object size will be smaller. Okay, let's go to the next one, the next drawing. In this next drawing, we have the object placed at focus. So let me place the object at focus. Oops, need this. Okay, so first line parallel to the principal axis, second one passing through the optical center. So we know what will happen to this line, this will be passing through F. Okay, done. It's a very clear drawing. So obviously we can see what is happening here. The two rays after the refraction, they are becoming parallel. These two are parallel lines, we can see. So obviously the image will be formed at infinity, because we know image will only be formed if there are the two lines are meeting at a point. So technically these two are not meeting, they are in parallel, so they are not meeting, that means they are meeting at infinity. So if they are meeting at infinity, the image will also be formed at infinity. And since it is the lights after diffraction is converging, okay, so means they are not converging in the sense that the line after refraction, they are bending inward, so it's inverting, so it will be inverted image. So it's an inverted image at infinity and real. And if you go to the infinity, if you go that, though it's not possible, but if you mathematically, if you say that if you go to infinity and measure the distance of the image from the optical center, that will be infinity, so it's a highly enlarged image. So if you go for the characteristics, then characteristics is real image, it's highly enlarged and formed at infinity and inverted. Now let's check the last one. Okay, so now we will place the object between focus and optical center. Okay, so if the object is placed between optical center and focus, then what will happen? Let's see. So first I need the light which is coming parallel to principal axis. Next I need this line. Now to draw the image, okay, so this is what we are getting. So we can see what is happening here. The two lights, after the refraction, they are diverging away from each other. So now we know what will happen. What we have to do, we have to draw this. We have to draw the image at the behind the object. That means we have to draw a virtual lines. We have to draw virtual lines from these two. Let's do that. Okay, so I will draw the virtual line. I'll draw it with little thinner line. Let us consider this one as our virtual line. Okay, I need to increase the size of it. So to do that, let me, okay, now I will draw this one. Now this one. Done. So this thinner line, let us consider this thinner line as the virtual line. So if we see that the virtual lines, then they are also meeting, they are meeting at this point. So obviously this will be the image. This will be where our image formed. I'll draw the image like this. Done. Okay, so this is the image. So what happens in this case, we can see the image is larger. It's larger than the object size. So the image is, since we have drawn it from virtual lines, so it will be a virtual image. Is virtual, it's enlarged, it's highly enlarged, and also it is upright or erect image. Why erect, why upright? Because the object is standing up, the image is also standing up. In all previous cases we had the images inverted and real. This is the only case, this is where only one case of convex lens where it forms, where it creates a virtual image. So also in converse we can say that convex lens is the kind of lens which forms both kind of images. It forms real image, it forms also virtual image, and this is the case where it forms a virtual image. Alright, these are the all drawings required for your convex lens, and that's it for today. And all the characteristics also I have explained. I hope you will understand. If you check this file, where all the drawings are given and all the properties are discussed here, okay, you will understand it better. Okay, that's it for today's class. We'll do the next class on the concave lens. Thank you.